Notes day 2, just to give you the heads up from the get-go, we're going to do one page front and back, and then when we get to the second page, this is, I don't know what to call it, day 2 of day 2, day 2 part B. We'll do that tomorrow. So when we called it, we didn't call it day 2, we called it notes 2. So this will be notes 2, second day. Day 2-2. Whatever. We're doing one page front and back. All right, properties of limits. These properties work like you think they should work. This is nothing big here. You can add limits. You can add the functions and then take a limit, or you can take the limits separately and then add them back together. The fancy way to say this, I'm only going to write this for one of them, and you don't have to write it down. The limit of a sum, that would be this side, the limit of a sum equals the sum of the limits. So those are different things, but it happens that they're equal. The limit of a sum is the sum of the limits. The same thing with the difference. The limit of a difference equals the difference of the limits. That's how you think it should work. So this isn't really a big deal. Like it works like you think it should work. The limit of a product is the product of the limits. The limit of a quotient is the quotient of the limits. And I guess there's not as cute of a way to say this last one, but if there's just a constant, then that k can go inside or outside the limit. It doesn't matter where you put it. That seems like it should work. Like you could slide the multiplier in and out. All right, here's the big difference with today. Yesterday was methods for evaluating limits graphically. That was yesterday. Day 1, graphically. Day 2 is going to be algebraically. So you got the hang of it yesterday, and it was pretty easy. You just looked at the picture, and as long as you knew what you were looking for, like, you know, coming from the right, coming from the left, do they match? Like, that was pretty easy once you got the hang of it. Today is not too bad, but there aren't any pictures today. Like, we're going to have to do some algebra work today. The first method, and this is so important because it works, doesn't work all the time, but if you skip this method, you end up doing more complicated things than you need to do. The first method you try is substitution. And if substitution works, then you're good. Like that's what, see if you get a real number. Because if you do, you're done. So substitution just means, well, let's plug in 1 and see what we get. So 1 goes in for x in top and bottom. So that would be -4 over -2, and that would be 2. If you get a real number, that's your answer. So if that seems easy, it is. The trick is we usually rig them so they don't work with substitution. But you have to try it first, because if it does, you're done. And if you skip to the next methods are much harder, and you end up doing more work than you need to. So again, first pass on limits is always, just substitute and see what you get. So 4 plus 2 over 3 times 2 plus 10. That would be 6 over 16, which is 3/8. That's a real number, so we're good. Again, if this seems easy, it is. You like this kind. You hope that it works, because if it works, then we're good. Plugging in 0, that's even easier than any of the others. You get 5/3. 5/3 is a real number, so that's the limit. Let's see, plug in 0. What's the cosine of 0? 1. And then 3 times 0 is 0. Uh-oh. That's not a real number. You can't divide by 0. So this does not exist. You could also think of this as 1 divided by a very small number, because it's as x approaches 0. So we may not get to 0, but as we get really, really close, let's see, what's 1 divided by a very small number? I'm trying to think how to phrase this. A real world example. Something that's very small. Grains of sand. Rice. So how many grains of sand could I fit on one earth? Well, a lot. A whole lot. Approaching infinity. And the smaller the grains of sand get, the more we could fit. So if you get 0 in the bottom, it means you're headed toward infinity, maybe negative infinity, depending on the other signs. But either way, this is not going to work. So there may be other things we can do. We're not worried about those other things right now. We did this problem in calculus today because what we do next with it is a calculus thing. Let's see, sine of x over 7. Well, plug in 0. What's the sine of 0? Sine of 0 is 0. What's 0 divided by 7? 0. Right? If I have $0 and I want to share it with my 7 friends, I can do that. Each friend gets $0. And 0 is a real number, so that's okay. So that old no and okay thing still kind of works. 0 in the top, okay. 0 in the bottom, nope, something's wrong. E to the infinity. E to the infinity over natural log 2. So natural log 2 is just some number. What's e to the infinity? Big or small? Big. E is 2.7. To the infinity means 2.7 times 2.7 times 2.7 times 2.7 forever. So really, really, really big. So infinity dne. And then lastly, 1,000 divided by 2 times infinity minus 4. So what's 2 times infinity minus 4? Big or small? Yeah, a lot. Really big. So this is where the math gets a little funny, and calculus students still make fun of me, but what's 1,000 divided by a lot? Small. Good. Right? In fact, if I had $1,000 in my pocket, I don't rob me. But if I did and I wanted to divide it up among everybody on Earth, tell me how much approximately would each person get? They'd get about $0. And the more people on Earth they are, the closer to 0 it would get. So as x gets bigger and bigger, this limit is 0. Okay, here's sort of a summary of some of the weird stuff that happens. When you plug in your x value, if you get a real number over 0, then your limit is infinity. Right? Because if how many grains of sand can fit on Earth? Well, a whole lot. If it's sort of the other way around, if you get 0 over a not real or a real number, this is if I have $0 in my pocket and I divide it among my 7 friends, well, they each get $0. Next column. a non-zero real number divided by infinity. So if I have $1,000 in my pocket, divided among everybody on Earth, well, $1,000 was nice, but everybody gets $0. Sorry. And then infinity divided by a real number. So if I have infinite, it's hard to think of something that's infinite. If I take infinite divided by 2, well, that's still infinite. So yeah, I can't really cut infinite in half. So the infinite and zero stuff is kind of tricky. Don't memorize it. Think about it. Think about dividing your $1,000 among everybody on Earth. Think about dividing your $0 among your 7 friends. Think about trying to cut infinity in half. It doesn't work. The more interesting should probably be in quotes there, right? Like, interesting to who? Whenever a math teacher says interesting, it really means difficult. Right? You can make that substitution most of the time. The more interesting limits, code word for difficult, are when we get an indeterminate form when we plug in the x value. So if we get 0 over 0 or infinity over infinity, what does that mean? 1 to the infinity. It's like there's conflicting rules, right? 0 in the top is 0. 0 in the bottom is no. So what do you get when it's 0 over 0? We don't know. It's indeterminate. 1 to the infinity. Well, 1 to anything is 1, but if we raise it to infinity, maybe it's not 1 anymore. These are some weird stuff going on. We're only going to worry about kind of the normal ones. The normal indeterminate, the normal weird ones. Weird and extra weird. We're just going to deal with the weird. Mainly because we have calculus solutions to these. If you plug in your x value and you get one of these forms, you must proceed with a technique that will allow you to manipulate the function so that you do get a real number. So like you have to do a trick. So now we got to learn some tricks. So if you get one of the weird forms, then you have to do an algebra trick. That's the point of the second page. If you get something that doesn't make sense, you got to do an algebra trick. In calculus, you'll learn the calculus trick for these, but first let's worry about the algebra trick. First trick is if you have a rational expression and you get 0 over 0 after plugging in, this means you have a hole in the graph at that value of x. You remember that? When you got like x minus 2 over x minus 2, that meant there was a hole at x equals 2? Well, it's kind of the same thing. If you get 0 over 0, that means there's a hole there. But holes have limits. So if you can get rid of the hole, then it's not indeterminate anymore. It's whatever that y value is. Most of the time, or our first algebra trick, the only one we're going to talk about today, we'll learn about some more tricks tomorrow, but the first trick is simplifying fractions, reducing fractions. You must have strong factoring skills in calculus. Yes. But again, we substitute first. So let's plug in -2 and see what we get. So -2 squared minus 4 times -2 minus 12 over -2 squared minus 4. Substitute first. 4 plus 8 minus 12 over 4 minus 4 equals 0 over 0. Although 0 over 0 isn't really an answer, so I'm going to go back and say it's not equal to 0 over 0 because that's not legal. This is a calculus. It's a big deal in calculus. It's not so big a deal here, but you should start thinking about this. 0 over 0, that's not a number, so I can't write that as an answer. Okay, but if I get 0 over 0, that means there's a hole at negative 2. So let's try to factor and see what happens. X plus 2, x minus 2 in the bottom. In the top, let's see, 6 and 2 would work. If it's plus 2 and minus 6, oops, x plus 2 and x minus 6. What can we do? What can cancel? Yeah, the x plus 2's, which means there's a hole at x equals negative 2. We already knew that. So let's try again. Let's plug in negative 2 now. Negative 2 minus 6 over negative 2 minus 2. That would be negative 8 over negative 4, which would just be 2. Let's try B. Probably going to be the same thing. If I plug in 3, 9 minus 9 is 0. Plug in 3 in the bottom. 9 plus 3 minus 12. 0 over 0. I am carefully not writing equals to, because in calculus you will lose points if you write equals 0 over 0. So I'm kind of doing everything, but just not writing the equal sign. So something's going on at x equals 3. Let's factor. Let's see, x plus 4 and x minus 3. You got to be able to factor. I'm not taking time to factor. If you can't factor, this is going to sound bad, but if you can't factor, don't sign up for calculus. Like, you just don't waste your time, because it's not going to work. The x minus 3's will cancel. That means there's a hole at 3, but we kind of knew that already. Let's plug in 3. So 3 plus 3 is 6. 3 plus 4 is 7. So the limit is 6/7. So that means there's a hole at 3, 6/7, if we're thinking about doing the graph of this thing. Let's keep going. If I plug in 2, I get 4. No, I don't get 4. I get 8 minus 2 minus 6 over 4 minus 4. You got to be able to do math quickly, or else this just takes forever. 0 over 0. If you get stuck, factor the easy one first. We know that a factor is supposed to cancel, so I'm pretty sure that x minus 2 needs to be one of those factors of the top so that it can cancel. So I need a 2x to get the 2x squared. I need a 3 to get the negative 6. And now it's just which sign will work. Plus 3. X minus 2's will cancel. I plug in 2. I get 7 over 2. Let's do one more of these. These are getting kind of repetitive here. Letter D. If I plug in negative 3, I get negative 27 plus 27 over 0, which is 0 over 0. Again, I'm carefully not writing in the equal sign because it doesn't really equal 0 over 0. So how do I factor x cubed plus 27? It's not x plus 3 times x plus 3 times x plus 3. What's the little saying that helps me factor cubes? There it is, SOAP. Now, SOAP is great, but it only tells me the signs. X and 3, and then square the first one, multiply the two together, square the second one. The x plus 3's cancel. Now we can try substituting again. So negative 3 squared minus 3 times negative 3 plus 9. That would be 9 plus 9 plus 9 would be 27. E and F are just more of the same. We don't need to do E and F. Star down there at the bottom. Do not write that a limit is equal to 0 over 0. If you do, we will not give you full credit for your answer. A limit is never equal to 0 over 0. Or infinity over infinity. Like, you have to do something to clean it up if you get that. So here's your solution. So you may not know that ahead of time. So if you put equals, then you need to go back and say, whoops, just kidding, it doesn't equal that. I need to go fix it. So if out of habit you put equal signs, that's fine. Go back and change it. Say, whoops, I didn't really mean that, because it can't be 0 over 0. So you have to show your work, but you got to be careful about the equal sign. All right, today's assignment is not all of worksheet 2, because again, we've sort of split up worksheet 2 into 2 parts now. Today's assignment, worksheet 2, 1 through 9. So factor and cancel, or plug it in. Actually, substitute first and see if it works. Thursday's assignment will be the back half of worksheet 2, 10 through 18. So again, we've divided day 2 into 2 days because the algebra tricks, we need to slow it down on these. So the trick for today is, or the 2 things for today is, try substitution. If it doesn't work, go to your bag of tricks. And right now, your only trick is factor and cancel. Tomorrow, or Thursday, we'll learn 2 more tricks to help simplify limits. But today we only know 1 trick. That's pretty easy, because if it doesn't work, it's going to be the trick that you know.